Hello guys, welcome to new playlist most commonly asked coding questions. In this we're going to discuss very basics to advanced questions in three languages: C, Java and Python. And in this video we're going to discuss first three questions: leap year or not, prime number and prime number within given range. So don't skip these questions because the first two questions, leap year and prime number, are most commonly asked questions in more than 90% of interviews, right? And I am explaining in C, Java and Python. First mainly learn in C language because nowadays most of the companies are asking to code in C language. So you need to know the basics of C language. I am explaining in this video. And let's start with leap year or not. The first question is leap year. Most of the people doesn't know the background behind leap year. They just know three conditions. By checking those three conditions, they will determine whether an year is leap year or not. What if the interviewer asked you, why are you checking those three conditions? What's the reason behind it? Then you will be in trouble, right? So you need to know the background behind leap year, why it is introduced. So basically, the number of days taken by Earth to revolve around the Sun is approximately 365.2425 days. Not exactly 365 days. So what our calendar is showing, a year has, a normal year has 365 days. So but it's not actually 365 days. It's 365.2425 days. So let's take, yeah. So what about this extra 0.2425 days? So for that only the leap year is introduced. Basically 0.2425 days per year. So our calendar is not showing those 0.2425 days. So it is behind what it should be in actual. So this 0.2425 days per year is approximately 0.97 for every 4 years. So our calendar is showing approximately 1 day for every 4 years. The calendar is behind that. So for this case, they have introduced a new concept called leap year. What exactly leap year is? For every 4 years, we are adding a new day to the calendar so that the equilibrium is maintained. So for that, leap year is introduced for every 4 years. So before it was minus 0.97 days for 4 years. So after introducing the leap year, 1 day extra is added. So it not corrected the calculation, right? So even though if you add 1 day for every 4 years, you will get around plus 0.03 extra days for every 4 years. Are you getting? Before the calendar was 0.97 less days for 4 years. If you add an extra day for every 4 year, then it would be 0.03 extra days for 4 years, no? So there is a problem here also. You might be thinking, what will happen if we ignore those days? This 0.03 extra days for 4 years is approximately 3 extra days for every 400 years. Are you getting? What will happen if 3 days are added? So there are seasons like summer, winter, rainy, and those are coming in particular months. So if we leave these 3 days, what will happen in future after some thousands of years? The seasons may go out of range, no? So to maintain that, we should calculate and build up the calendar. So for that, another exception is added, that is 100 years alignment. So for that, what they have done is, there are coming 3 extra days for every 400 years. So why not we skip a leap year, one day for every 100 years. So what they found solution is they skip leap years every 100 years. So for every 100 years, one leap year is skipped. So by doing that, what happens? Before it, there was 3 extra days for every 400 years. For every 100 years, they skipped one leap year. So how many days are skipped? 4 days are skipped. Then it would be resultant to -1 less days for every 400 years. So here also the problem not solved. So even though you skipped a leap year for every 100 years, now what happened? The calendar is behind what it should be actual. So for that they have taken another adjustment, that is 400 years adjustment. So what they have done is, what's the problem here? For every 400 years, the calendar is 1 day less than that should be in actual one. So what they have done is, they have added 1 day as a leap year for every 400 days, sorry 400 years. So for every 400 years, 1 day is added. So now 0 days. So are you getting the point? First, it is minus 0.2425 days behind that should be actual for a year. That is approximately, that is approximately 0.97 days for 4 years. So for that they have added 1 day for every 4 years. It result into plus 0.03 extra days for 4 years. So it's approximately 3 extra days for 400 years. So what they have done, there are 3 extra days. So we are skipping 1 day for every 400 years. So by doing that, it would be -1 days for every 400 years. So what they have added, they have added one more extra day for every 400 years, so that it resultant to 0 and the calendar is maintained. So I have prepared a solution for every questions. Most commonly asked questions, I have prepared solutions. It will be in the description. If you go thoroughly, you can understand it. And the codes are also written here in Python, Java and C. First, a leap year. This is main. Actually, this is the final concept you all know, but you don't know the story behind it, right? Adding a leap year every 4 years keeps the calendar in sync with the Earth's orbit, right? Skipping leap years every 100 years prevent too many leap years. And after that, adding back leap year every 400 years corrects the over adjustment. That's it. So what's the net effect here? This combination ensures that the calendar average is 365.2425 days, almost perfectly matching the Earth's orbit. And there is a slight error, that is 26 seconds per year. So that is negligible, right? So this is the concept behind leap year. So do coding now. So you should not skip these basic concepts. Why? Because even though you are a perfect person, at interview you will face some tensions, right? And even though it is simple leap year program or a prime number program, you might get in some trouble. So if you thoroughly learn and take a book and note down these all problems, then you will be confident to solve them. So first, I will explain in C language. Why C language is, basically all MNCs or any startups, they are asking codes in C language nowadays. So they don't want in Python or Java. Why? Because if you are a expert in C language, then automatically you can code in Python and Java, right? In C language, the main advantage is you know from the basics onwards. So C language, we don't use any predefined functions for sorting, for any other things. So if you start coding with C language, you will not use any predefined functions like sort or min, max. Those are used in Python and Java. So your basics will be strong. So let's solve in C language. First, we will take an year, which is integer, and let's take an year 2000. We should find whether the year 2000 is leap year or not. So what's the first condition? We should check for every 400 years it is leap year or not. For we have added for every 400 years it is a leap year, right? So I will explain. So at final what we have decided, yeah, we have added 4 years. For every 4 years there is one leap year, and for every 100 years we are skipping, and for every 400 years we are adding. Right? If there is any year which is 2000, so how to check is there are 3 conditions. First one is divisible by 4, because for every 4 years we are adding one leap year, right? So 2000 divided by 4, we will check that condition. And this is also point, we will skip for every 100 years. So the condition should be like this: the year should be divisible by 4, but it should not divisible by 100. So this is the first case, right? Are you getting this? First, the year should be divisible by 4, because for every 4 years we are adding a leap year, but we are skipping for every 100 years. So it should not divisible by 100. And after that, the other condition is for every 400 years we are adding. So year for percentile 400 should be equal to 0. That's it. By checking these 3 conditions, we will determine whether the year is leap year or not. Right? First, we will check condition like year percentile 400 double equal to 0. In this case, it is leap year. This is one condition. And not after, in C language we use or these 2 pipe symbols. You should know that. In Java and Python those are different. I will explain that also. You should remember that in C language for OR operator we use this, and after that we will check a condition like year percentile 4 double equal to 0. The year should be divisible by 0. For every 4 years we are adding a leap year, but there is a condition: year percentile 100 should not equal to 0. Why? Because we are skipping a leap year for every 100 years. So this is the main conditions that you gonna remember. So note it down. And after that, if the condition is true, then we need to print whether it is a leap year or not. Print percentage D is a leap year. Right? After that, in the case of percentage D, what we should want to print? Year. So write here year. That's it. And else case. In the else case, what we should print? The year is not a leap year. Simple. Not a leap year. That's it. Let's run the program. Sorry. In C language, yeah, you need to know this only. If you are in Python, you will write print, right? But in C language, there is a there is no print statement. There is printf statement. So this kind of technical you should know. So that's why I'm explaining in these three languages. So you are confident whenever you are in interview, right? Yeah, 2000 is a leap year. And we will check another 2001. 2001 is not a leap year. So why 2000 is leap year? It is divisible by 4. 400, yeah. Even though it is divisible by 100, but for every 400 years we have added one more leap year. That's why 2000 is a leap year. So let's come to time complexity. So there are no loops here to check. So obviously the time complexity is big O of 1, which is constant. And what's the space complexity? Space complexity also same. We didn't use any extra space, any extra variables to solve. So the space complexity also big O of 1. So let's solve in Python. First, we will take an variable year equal to 2000. And after that, we will check condition. If there are two conditions that we're gonna check. Year percentile 400, that should be equal to 0. And here we will not use that pipe symbol or that like that. We just use OR. And there is other conditions. Year percentile 4, that should be equal to 0. And we will write and directly in Python. And year percentile 100 should not equal to 0. So that's it. And if this all true, then we should print. Here we will use print statement, not printf. Print here also we can use so many things. I am using this percentage d is leap year. And after that, in Python we can't use direct comma and write. Like in C we have used this comma here. In Python we should use percentile. Percentile, and what variable should come in the place of percentage d? That is year. So that's it. And after that, if the if condition is failed, else case. And else case we should print it is not a leap year. Not leap year. Yeah, as you can see here 2000 is a leap year. Let's try for 2001. 2001 is not leap year. Yeah, the time complexity is same as here. We are not using any extra things. So the time complexity is big O of 1 and the space complexity is big O of 1. But in Python, for writing comments, we're going to use hash. So these basics that you need to know before doing coding, right? So if you follow this entire playlist, you will get to know all the basics from C, Java and Python, so that it is easy to solve problems. And after that we will see in Java. We will take year, let's take 2000. And after that we will check condition. If year percentile 400 is equal to 0. In Java we're gonna use this pipe symbol. And year percentile 4, that should be equal to 0. And same as C language we're gonna use and here year percentile 100, that should not equal to 0. So if this condition is true, that we're gonna print. In Java to print, we are not able to use printf or print. We're gonna use system.out.println or printf. So system.out.println, we're gonna use percentage d is leap year, and after that what should come in the place of percentage d, that is year. Yeah, we are not able to use println here. In println it takes normal text only. If you write printf, in that case you're gonna use percentage d, percentage f, all that kind of stuff. Same as C language. If the if condition is false, then we're gonna go to else condition. In else case, we should print the year is not leap year, not a leap year. That's it. Yeah. To in the place of percentage d, year should be print. So to print like this, you gonna use printf statement. So you should remember this. We're gonna discuss so many kind of outputs that we're gonna print. So in this case, I am using printf and percentage d. There are so many types. We will discuss in further next problems. So let's run the code. Yeah, 2000 is a leap year, and we will check for 2001. Yeah, 2001 is not leap year. So the time complexity and space complexity, that is same as Java and the same as C and Python. And in Java, to write comments, we're going to use 2 forward slashes. In Python, we're going to use hash, and in C, we're going to use forward slashes. If you still have any doubts about leap year, then the solutions PDF is at description. You're going to refer this. Yeah, next, prime number. Yeah. Leap year or not, this is completed. Next, prime number. Prime number, it is a very basic coding question. Most of the people know about prime numbers, and some might face difficulty in coding. And so to discuss about prime number, first you need to know about a divisor. A divisor is a number which divides the other number completely with remainder 0. So that is a divisor. And when it's come to prime number, the prime number should have only 2 divisors, that is 1 and the number itself. So in other words, a prime number is a natural number greater than 1 that has no divisors other than 1 and itself. Are you getting? The divisors are exactly 1 and number itself. So what are the examples of prime numbers? 2, 3, 5, 7, 11, 13 and so on. So let's discuss in detail. I am taking 2 numbers. Those are 13 and 14. Yeah. So let's see the divisors. So first 13. So is 1 is divisor of 13? Obviously, when 1 is divided by 13, it remains 0, remainder is 0, and 2, no, 3, no, 4, no, 5, no, 6, no, 7, no, 8, no, 9, no, 10, and so on, 13. There are no other divisors other than 1 and 13 in between that divides 13 and give remainder 0. So in this case, 13 is a prime number. So let's see another number, 14. Is 1 divides 14? Obviously yes. 1 divides every other number and gives 0 as a remainder. So, and after that 1, 2. 2 also divides 14. 2 sevens are 14 and remainder is 0. 3, no. 4, no. 5, no. 6, no. 7, yeah, obviously 7. 7 2s are 14. 8, no. 9, no. 10, 11, 12, 13 after 14. If you observe clarity, 14 has 4 divisors. So other than 1 and 14, there are 2 other divisors that divide 14 and give 0 as a remainder. So in this case, 14 is not a prime number. So if there are any other divisors between 1 and the number, then it is not a prime number. In this case, 14 has 2, 7. In 13 has no. So this is prime. This is not prime. So how to code it? So let's discuss the pseudocode. Yeah, I'm checking for number 14. Let's see, n is equal to 14. So for 14, we are checking other than 1 and 14, we will go like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We will go from 2 to 13 and we will check whether this every number is divisible by 14 or not. Are these numbers divide 14 and give remainder 0 or not? So how to get these all numbers? Use a for loop. For I is equal to, we will start from 2 and after that I less than 14. I less than 14 means up to 30 numbers we will get, and I plus plus. So what this for loop will generate? It will generate numbers from 2 to 13 and those numbers are stored in I. So after that, in every case, we will check whether I, that is a particular number 2, 3, 4, which divides 14 or not, whether it is a divisor or not. What is a divisor? It will, whenever the division is done, the remainder should be 0. So the same case we will be checking if the number 14 percentile I double equal to 0 or not. Whenever the remainder is 0, then it is not a prime. So to assess that, we will take another variable which is flag and we will initialize with 0. And whenever after division the remainder is 0, then we will update the flag value as 1. So after that we can check the condition, like if flag is equal to 0. When flag is equal to 0, then this division not takes place. No, 0 is not obtained whenever the division is performed. So it is a prime number. Else print not prime. This is a basic prime number program. So what's the time complexity here? So how many checks are done? The checks are done from 2 to 13. So for number 14, for number n minus 2 checks are done, right? So what's the time complexity? Obviously big of n minus 2, that is big of n. Can we optimize this program? So how can it done? If you see, even though whenever the division is performed by I and the remainder is 0, here the flag is updated. After flag is updated to 1, is there any need to again check? No. Why? Because whenever, in this case 14, first 2 is checked, right? Here whenever 14 is divided by 2, then 0 is the remainder, obviously, and here flag is equal to 1, it is updated. So we need only one extra divisor to determine whether the number is prime or not. So why not break the loop here? Yeah, we can now. So we can write break statement here. We can add Yeah. By adding break statement in if condition, whenever this if block is executed, we got a new divisor. So break statement is executed and there is no need to be check all these other cases. In this 14 number, only first 2 is checked and these entire numbers are skipped. So whenever 14 is taken, what's the time complexity then? Obviously big of 1, constant. And the problem is not completely solved regarding to time complexity. What if the number is not 14, the number is 13? So in this case, from 2 to 12 numbers are checked, but the if condition is not executed, no. So break will also not executed. So in that case, it will completely execute all these cases. So in that case, the time complexity is obviously big of n. So by adding break statement, the time complexity is not reduced. So can we do some other thing to reduce the time complexity? Yeah, most of the people know that, know this case. We will just reduce n number of checks, we will reduce to n by 2 number of checks. Why? Because there is no divisor greater than n by 2. So in this case 7, we will get divisors up to 7 only. So after that 8 to 13, these numbers will not divide 14. So in that case, what we will do? We will just update this 14 as less than or equal to 7. So in this case, for number 14, n, we are checking from 2 to 7. 2, 3, 4, 5, 6, 7. And the same algorithm follows. And in this case, what's the time complexity? The time complexity somewhat reduced because before n number of checks are done, but now n by 2 number of checks are done. So what's the time complexity? Big O of n by 2. That is partially equal to big O of n. So here also the same problem arises. So can't we reduce the time complexity less than big O of n? We can reduce the time complexity to big O of root n. So how to do? So we can just check the conditions up to root 14 less than or equal to root 14. In that case, we will get time complexity of big O of root n. First we have checked up to n, after that n by 2. Now we are checking up to root n. So is it correct to check up to root n? So I will explain in the solution PDF. I have explained. Yeah. Limit divisors to root n. Let me clarify the reasoning behind why we should only check the divisors up to root n when determining if a number is prime or not. So if n has a divisor d, then n can be expressed as n is equal to d into k, right? So where d and k both are divisors of n. So take case analysis. If d is less than or equal to root n, so we are checking about root n only. If d is less than or equal to root n, the corresponding factor k will be greater than or equal to root n, because both can't be less than root n, no, because when they are multiplied, n should become, one should be greater than root n and one should be less than root n. In this case, d is tested in the loop since it is smaller than or equal to root n. Let's take another case where d is greater than root n. So the corresponding factor k is obviously less than root n. In that case, k would have already been tested earlier in the loop, right? Both numbers can't be greater than root n because root n into root n is equal to n, no. So one must be less than or equal to root n and other should be greater than or equal to root n. So by checking up to root n, we can find whether the number is prime or not. So if a number has a divisor greater than root n, it must also have a corresponding divisor smaller than root n. This is the point I have explained. By the time we finish checking all numbers up to root n, we will have identified whether n is divisible by smaller factors. If no divisors are found by n, n is prime. So let's take an example, that is 36. By taking example, you will understand deeply what are the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, 36. So let's write the pairs like 1, 36, 2, 18, 3, 12, 4, 9 and 6, 6, 6. For every factor d greater than root 36, like 9, 12, 18, 36, there is a corresponding factor d dash less than root 36, like 4, 3, 2, 1. So by checking divisors up to root n is sufficient. Are you getting? So in this case, by just checking up to root n, we gonna say whether the number is prime number or not. Most of the people might facing some problem whenever they are writing prime number program in a main function or in any other sub function. So main program and any other function. So let's discuss both so that you will not get confused. In main program, as we discussed, what we will be doing, int a number n and let's take as 14. And after that, we will check a condition by for loop for I is equal to 2, I less than or equal to root n, I plus plus. And after that, first we should also take a variable flag and initialize to 0. And after that, we will check a condition if n percentile I double equal to 0, then flag is equal to 1, break. Completed. And after this running for loop, whenever this if condition is not executed, then obviously it is a prime number. So we will check a condition if flag is equal to 0, then it is prime. Else not prime. Yeah, and this program is in main. After that, let's see in a function. So in function, the logic is same, but the return statement comes into action, and not all members might confuse, but some people 0.1% or 1% people might confuse. That's why I am explaining in both the cases. Like in function, let's take function which is prime. So in that is prime function, what you will be doing? First, directly if condition for loop is taken, because n is the input to the function. So for I is equal to 2, I less than or equal to root n, I plus plus. So in this case, flag is not used. So we will just check a condition if n percentile I double equal to 0. In that case, what we will do? We will just write return statement. Why? Because this is prime is checking whether the number is prime or not. Let's take the return type is int. We should return a number that is an integer whenever the division is done and the remainder is 0. Then it is not a prime number. So return 0. 0 means it's not a prime number. 0 means false. So whenever the entire for loop is executed and if condition is not executed, then obviously it is a prime number. So prime number we should return 1. Yeah. The reason behind why I have explained in the both the cases is whenever you are writing the prime number in a function, you need not to be take a flag variable, and you can take flag variable and solve it. But whenever you are going to an interview, if you type prime number program in Google, then obviously 99.9% you will get this function code only. So in that time, you mainly prepare this main function code, and at time before the interview, you will see this code. Then you will be in trouble, no? So that's why I have explained these two cases. So let's do coding. Yeah, I'm writing in a function. So in C language, first we should define a function. Yeah, it should have a return type, that is integer. It is returning 0 or 1, and function name is prime. And after that, the parameter we should pass an integer, and that is n to this function. And after that, yeah, and after that we will take for int I is equal to 2, I less than. Here, how to get root n in C language? So this you need to understand. So that's why I am explaining in C, Python, Java. So there are some basic things that you don't know in other languages. So in Python, you should import math.h. So hashtag include math.h. Yeah, after including this math.h, we're gonna use that. To get a square root of a number, there is a function sqrt, less than or equal to sqrt of n. So without importing math.h, sqrt function will not run in C. So after that, I++, yeah, and after we will check a condition. If n percentile I double equal to 0, in this case we will return 0, and after the complete execution of for loop, we will return 1. So the isPrime function is completed. And when it comes to the main function, first we need a number n, int n is equal to, let's check, we are taking 4, and after that we will check if is prime. I have said earlier, in programming languages like C and Java, 0 means false and 1 means true, right? And is prime of n, if this is prime of n is returning true, then only if condition is executed. So if is prime is returning 1, then it's a prime number. So we should print n is prime number, no? Printf percentile d is prime. And what's the number? N. Else same, not prime. So what's the time complexity? As we have discussed, we are checking up to root n. So big O of root n. Big O of root n. What's the space complexity? We haven't used any new things, no? big O of 1 constant. That's it. Let's run the program. Why 7 is not prime? Yeah, here n is checked with I, not n. There's a typing mistake. Yeah, after correction, yeah, 7 is a prime number. Here I have typed 1 instead of I, so that's the problem. Can we even optimize this code? Actually, the time complexity can't be less than big O of root n, but we can reduce the number of checks in each prime function. So how that can be done? Let me explain. If a given number is less than 0, then is it needed to check all the things? No, we can write a if condition. If n is less than 2, then obviously it is not a prime number and we will return 0 here. And after that, if n is equal to 2, then obviously it's a prime number. 2 is the only even prime number. So we will check that condition also. If n is equal to 2, then return 1. So it's a prime number. That's why we are returning 1. And here comes the case. Whenever you are checking the divisors, let's take 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are checking from 2 to 10, the I ranges from 2 to 10. If you clearly observe, by just checking whether the given number n is divisible by 2 or not, we can skip all the even numbers. No. Why? Because if the given n number is divisible by 2, then obviously it is divisible by 4, 6, 8, 10, right? Even if it is not divisible by 2, if n is not divisible by 2, then obviously it will not divisible by 4, 6, 8, 9, 10. Are you getting my point? Why? Because here 4 can be written as 2 into 2. The n number is divisible by 2. So it is divisible by 4 also. If n is not divisible by 4, then obviously it is not divisible by 2 also. Are you getting? So by just checking whether n is divisible by 2 or not, we can skip all the even numbers. So number of checks here is decreased by half. Are you getting? So let's do the modification. Here we will check another condition. If n percentile 2 double equal to 0. In this case, what happens? We should return 0 first. If the number is divisible by 2, then obviously it's not a prime number. No, it has another thing. It has another divisor. So return 0. We are writing a return statement after every this condition. You can ask if n is equal to 2, then here it is returning 1 and n is divisible by 2, giving remainder 0. It will return 0. So these two statements will not execute. Only one statement is executed. If n is equal to 2, then obviously return statement is executed and this all after code will not execute. So this if condition should be in a sequence. So after that, if you clearly observe, we have checked for 2. We no need to be checked for all even numbers. So we can skip one number here. So that's very efficient one, no? So we will start from 3 and we will skip one number. I plus plus, no? I am writing I plus equal to 2. By doing this, the number of checks has reduced to half. Are you getting? So first we will check whether it is a positive number or not. Up to negative number 2, up to 2 we are checking in this if statement and we are returning false. Why? Because prime numbers are starting from 2. Less than 2, all are not prime numbers. After that we will checking for 2. If n is equal to 2, then obviously it is a prime number. And after that, greater than 2. For greater than 2, to skip even numbers, we are taking another condition, if condition. First, we will check whether n is divisible by 2 or not. So, we can skip half of the cases, no. If it is not divisible by 2, then it is not divisible by all even numbers. So, this for loop is executed then. In this for loop, we can skip all even numbers, no. So, that's why we have started from 3 and we have skipped all even numbers and we have checked. The code, the code runs as usual. 7 is prime, and if we check n is equal to 4, here 4 is not prime. So, the code is perfect, but the time complexity goes from big O of root n to big O of root n by 2. That is equivalent to big O of root n. But you know what? The number of checks are decreased here. So, that's the point to be noted. So, let's see in Python and Java also. Yeah, you can refer my solution PDF. Yeah. In Python also the same thing. For defining a function, def keyword is used, is prime, and here directly n is passed without giving any data type mentioning. And if n less than 2, return 0. If n double equal to 2, return 1. If n percentile 2 double equal to 0, return 0. Same as C language. The same thing for I in range. For Python, we will use range function 3 to up to root n. In Python, to get root, we gonna use math.sqrt function. And after that we gonna add plus 1. Why? Because range function starts from starting to ending minus 1. So we need to check that root n also. That's why we are adding plus 1 here. And after that 2 is written. Why? Because we are all skipping the even numbers. This one condition, by just writing this one condition, we are all skipping even numbers. And the same, if n percentile double equal to 0, return 0. And after this for loop, return 1. That's it. If n is equal to 4, is prime of number, same as the C language. And when it comes to Java, in Java there is slight modification. Java doesn't take 0 and 1 as true and false in if conditions. That's why we're gonna use Boolean return statement. So in Java, to write a function public static Boolean, we have used Boolean is prime, and we need to give the integer data type of the number. So int number. If number less than 2, return false. If number double equal to 2, return true. If number percentile 2 double equal to 0, then return false. And after that, the same for loop, same as C language. Here math.sqrt. In C language, we have direct used sqrt of n. In Python, math.sqrt of n. In Java, math.sqrt of number. Same. Here also I plus equal to 2 and the same. After that, the main function here int n is equal to 3. If is prime of n, system.out.println. This println function wants a string to execute. Here whenever we place n here, n is converted into string and n3 is added here. And if we want to add any other string to it, we should concatenate it. So plus is used to concatenate, and after that space is a prime number. So this is how it works. And after, in else case, if it is say false, then only this else case is executed. The same as n is converted into string and this concatenation is done, and it is prime, not a prime number. So in every case, the time complexity is big O of root n. We got from big O of n to big O of root n here. So that's a drastic change, no? 2 questions are completed. Leap year or not and prime number. Let's go to the third question. Prime number within given range. Yeah, here a range is given like starting and ending n1 and n2. You should prime you should find how many prime numbers are there in that range. Let's take n1 and n2. N1 is equal to 10 and n2 is equal to 30. We need to find and 10, 30. We need to find number of prime numbers. Those exist in between those two numbers. And for that we no need to learn any new concept. Why? Because we have learned about prime number in the last question, and we have defined a function also, which is prime. What we will be doing is, we will give this number, every number input to the function, and this function will tell whether the number is prime number or not. And if the function tells it's a prime, just print the number, and if it is not a prime number, then ignore the case. That's it. The numbers are 10, 11, 12 and so on, 30, and each and every case, all the numbers, first 10 is given to the function, it will tell whether the number is prime or 10 is prime or not. It is not a prime number, so ignore. And after 11 is given, 11 is a prime number, so print 11. Like that, the loop consists, and it will go up to 30 and break. So what's the time complexity here? How many number of checks are done? How many numbers are given to the input to the prime number? That is from 10 to 30. So that's obviously 21 numbers are checked. Are you getting? N2 minus N1 plus 1. Let's take 1, 2, 3, 4, 5. How many numbers are there? 5 numbers are there. So how to get the count? That is N2 minus N1 plus 1. This will give the count of the numbers. N1 is 1, N2 is 5. 5 minus 4, sorry. Yeah. 5 minus 1 plus 1. Plus 1 minus 1 cancels and 5 is the answer. So same, N2 minus N1 plus 1. These many numbers are given input to this isPrime function. And what's the time complexity for isPrime function? That is big O of root n, right? So what's the time complexity for entire code now? That would be big O of approximately n2 minus n1 into root n. So this is the final time complexity for the code prime number with the given range n1 comma n2. And what's the space complexity? We haven't used any extra space here. We didn't declare any array, so the space complexity is big O of 1. So time complexity, space complexity. So let's do coding. Yeah, here it's a prime number function that we have written. So first, yeah, we need two numbers n1 and n2. That is a range. In between that, we're gonna find prime numbers. First, int n1, let's take as 10, and after that n2, that is 30. So for each number from 10 to 30, including 10 comma 30, should be given to the isPrime function. So let's take a for loop. For int I equal to n1 and I less than or equal to n2 I plus plus. In this case, all the numbers, including the starting and ending number, are given, and at every time isPrime function should be called, and it will tell whether the number is prime or not. So we should check if isPrime of what number? The number is stored in I. So if the number is prime number, then what we should do? We should print the number, right? Printf. To get a number in a print function, so we should use %d, and after that a space and comma I. So what this printf function will do? It will check the if condition will check whether the I is prime or not. If it is prime, then if condition is passed, the printf statement is executed. and if it is not a prime number, then if statement is not executed and basically it skips and the number is not printed. So what's the time complexity as we have discussed? The time complexity is n2 minus n1, that is number of checks, and after that for the prime number, what is the time complexity? Root n. Yeah, so that's the time complexity for this code. And the space complexity, we haven't used any extra variables or any extra arrays, so the space complexity is big of 1. So let's run this code. Yeah, as you can see, 11, 13, 17, 19, 23, 30. These are the prime numbers in the range between n1 and n2, 10, 30. So let's see in Python and Java also. I have prepared solutions document. You can refer this. Where's the third question? Yeah. Prime number with a given range n1 and n2. So here no new concepts are explained. Why? Because we are just iterating a loop from n1 to n2 and checking. So we have discussed the C language, and after that Python. Here also this def is prime we have defined in prime function code, and after that n1 is equal to 10 and n2 is equal to 30. New variables n1 and n2, and after that for I in range of n1 comma n2 plus 1. Why n2 plus 1? The range function takes like starting to ending minus 1. So to get 30 also I am doing n2 plus 1. And after that, if is prime of I, we will check whether I is a prime number or not. If it is a prime number, so print I, and here end is equal to, I am given a space here. Basically the default print statement has an end of /n, that means new line character. But if you want to change that, then we should write end is equal to, and what should come after the end of the print statement, that we're gonna put there. If you put /n, then new line character will come, and the numbers are printed in this vertical order. If you keep space, then the numbers are printed in horizontal. And even if you write some symbols also like exclamation mark, and at that time one number is printed, one exclamation mark, and other number, other exclamation mark, like that. You can modify the output syntax also. And what's the time complexity? The time complexity is n2 minus n1 into root n. Same. And when it's come to Java, we have written isPrime function before only. And after that, we are taking two variables, int n1 is equal to 10, n2 is equal to 30. And after that, iterate loop from starting to ending. So same as C language, int I is equal to n1, I less than or equal to n2, I plus plus, and check if is prime of I, system.out.print, and it takes string, so I is converted into string, and if I is a prime number, so I is printed, and after that concatenation of space is done, and so on. And first you need to learn in C language. If you learn in C language, easily you can code in Python and Java, right? Yeah. If you like my content, do like this video and share and subscribe, and give some feedback also, should I change anything in my teaching. And that's it for the video.